Hey everyone. For once, I'm not actually starting late, so already kicking it off on a high note today. But yeah, we're on to day 20 now, so this will mark the 80% of the way done mark. We'll see how it is. The past few days have been surprisingly. It's another grid problem. Lovely. The past few days have been surprisingly easy, but we'll see how today goes. Okay, right outside the CPU, got a racetrack. Yep, more start end. The fastest. Yep. Programs are allowed to cheat. Okay. I see. Okay. Interesting. So we just want to BFS from every point to the end and then see if any cheat saves significant time. Interesting. Okay. Um yeah, I guess to start we'll do which day was it that had this similar structure? Day 16 maybe? Yeah, this looks similar. I'll copy this over. We're gonna need to change a few things, I imagine, but shouldn't be that many things. Yeah, we'll do start, end. Honestly, this might as well just be the default starting point given how many grid problems there's been. So if it's start, we want to set that. If it's end, we want to set that. Yep, and if it's that, we want to set it as impossible. Cool. And then I think basically we just want a copy of the grid that's a BFS. Right, and then do for each point we want to check the distance to the end if it's a valid point. So if it's not 2, right, because if it's 2 we don't have to consider it. Actually we'll just mark it as like some very high number. What can we do if it's this? We'll just say BFS equals something clearly too high. So like grid.length times grid0.length. I mean, it obviously can't be bigger than the entire grid, and that makes it double the size. Although maybe we want to make it negative so we don't like shortcut into a wall. I don't think that's very important. It's fine. So the start point actually isn't important really for this day, so I think that's fine. Also, a unique start and end point is interesting. How would I record that? I guess I could just make a separate class for that. So I'll have a coordinate start and a coordinate end. And then I guess a int for a time save. I'm using ints in this case because the grid is pretty small, so any time save can't possibly be that big. BFS equals, we'll just come up with a method. So we want to do new coordinate. Actually, we can just pass an ij. ij exit. What did I call it? Oh, end. And then grid. Cool. So let's create that method. Coordinate end. Actually, rather than passing grid over and over again, I'm just gonna do that. That way I don't need this. Cool. Okay, so obviously if we're at the goal, then it's 0. Otherwise, we'll want to make a list of coordinates. What is it called? Yeah, technically I could make some sort of priority queue, but I don't think it's really necessary in this case. Oh, actually, what I could do is BFS from the end point out, right? Rather than BFSing from each point. Yeah, actually, let's just do that. Let's try that. So what we can do is, yeah, I gotta say though, I am kind of gridded out this year. I feel like there's been a ton of grid problems. I don't know. Maybe I'm just, my perception's just clouded. But I didn't really like the mega year 2019 either with Intcode. Although I do have a series on that coming out. But yeah, I wasn't a huge fan for some reason. Couldn't really tell you why. But I just feel like it gets kind of repetitive, I guess, if that makes sense. I'm still trying to figure out how this cheat works. So basically 2 picoseconds. So you can go through exactly one wall and have to go straight through. Oh no, you can go diagonally through maybe? Yeah, well, wait. I don't know if you can go diagonally through. I imagine you can. Yeah, seems fine. Okay. What are we doing here? So we still want the queue. We'll add end to the queue. We should have a scene as well. Cool. So what do we do while the queue is not empty? We basically just want to have a new one. And then for coordinate C in Q, we're going to need a counter as well. So for each coordinate, we basically want to set BFS c.x c.y equals counter. And then we want to do a for coordinate neighbor in how is it? Oh, I don't have the utils thing. I always forget that. I should remember to put that in. Yeah, having a helper method for these grid days is so useful. There's just so many different commonly used grid things, and I mean maybe the language you use supports them, but I feel like Java just doesn't have the greatest support for 2D grids. I guess maybe on purpose. Like you really don't use 2D grids that often except for this kind of problem. we already added end. Cool. And then we do q equals new q. Actually, before we do that, oh no, we can do that. And then scene dot add all. Actually, we probably want to. Oh yeah, this is fine. We just need to do scene dot add end. Cool. And then we return BFS at the end. Nice. Okay, so that gets us the grid and like the minimum time to get to the end. And then what we can do is, sure, for each point, we do that. And then we go do this again. And basically we do this as the starting point. How do I do this? How do I do this? Basically, what is the distance we want to consider, right? In 2 picoseconds, you can go there's only so many places you can go, right? So I can make like a list of them. Let's see. You could go straight left, one left, straight up, straight down, one right, straight right, something like that. I've just forgotten Java syntax apparently today. Good stuff. Yeah, again, this is such a straightforward grid problem. People who actually have good grid skills are probably done, but that's fine. Okay, cool. So we can then do int k equals 0, k less than x's dot length, k plus plus. If safe, let's see, s dot x plus x's k, y equals s dot y plus y is k. Cool. If this is safe, and this new point is what? It's less than the old point by how much? 100? 100. Less than or equal to. Wait, no, less than, right? Because the cheat takes 2 seconds. So it can't just be equal to, because if it's 100 shorter in time, yeah, I don't think that's it. Okay, we'll do less than 100. I think we just do, I thought I need a cheat thing, but maybe I don't. Oh, that's not good. So we don't use start at all, but I think that's actually correct here. Oh, whoops. And grid ij does not equal 2, because we can't have it end up in a wall. Okay, that's not the main issue. The main issue is the fact that everything's 0. For int row in BFS, trusty old printing of the grid. I should make a helper method to print the grid. Oh well. Yeah, there's plenty of things here. So I'm surprised it's not working. Should be like that, but that shouldn't really matter, right? Oh, these should be BFS. Okay. Still not fully confident I get the wording. Okay, let's try this one. Yeah, much smaller. Right, but there's nothing here. So let's switch to, what did it say? There's a one sheet that says 64 picoseconds. Let's see if we can find that. I'm on the wrong day. Wow, this is really going well. Interesting. We can't find that. What if we need the equal sign? Does that find it? No. Like those 2 picoseconds count, right? Oh, it only counts. Ah. Wait, what? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 16, 17, 18, 19, 20. Ah, okay, so it has to be on the path from start to end. Got it. Okay, so it's not just any path. Ooh, interesting. Okay, how do I actually think about this then? So one obvious thing I can think of is I could just generate at each grid where we're missing one point and like one wall and see how much that speeds up start by. But I don't know if that'll get me the right answer. Yeah, I'm saying that because there might be multiple cheats through a wall. Actually, can there be? Yeah, I think there can be, right? Like, if there's a wall surrounded by 4 empty spaces, maybe cheating through it one way will save like 200 picoseconds. Cheating through it the other way will save some amount of time. Now, how do I model any of that? It's a bit tricky. But also, wait, let's just see. What is start here? Start is 170? That doesn't really make much sense now, does it? In fact, it goes 0 to 4. What happened to like 1? Oh, this is on the wrong layer. In fact, all of these are on the wrong layer. Okay, so this was busted from the beginning. But is that better? 0. Oh, no. Can't go through walls for the BFS. Okay, so there is one. Like, what happens if I just do that here? This is an overestimate, but by how much? I guess I don't know. Yeah, I need to make it so it's only the ones that go through start. So I need a BFS from start to the point to equal something. Yeah, okay. So basically, I want a separate BFS for start. Right, so these two BFSs obviously will share things in common. But I want to confirm that it lays, like the point will be on start. So what I can do is here, if BFS, okay, so let's get this. Int current, so let's get rid of this print for now. Current distance equals BFS start.x start.y. Right, that's the way without any cheating. And then what we can do is if BFS ij plus BFS 2ij equals current distance, because this means it's actually on the hot path, then we do this. Also, this should be 1,000. Oh no, it was 100, right? Was it 100 or 1,000? 100. But also, how big is this grid? I mean, the grid's only, yeah, I don't know. That's a number. Oh, really? That's not the right number. That's surprising to me. It could be higher. Yeah. It's not this. It's if the end is after, like, post cheat is over 100 faster. So if safe and it doesn't end up in a wall, we'll redo this logic. If BFS 2 ij, so that's the distance from start to this point, plus BFS new x new y, which is basically the distance from this point to the end, is less than current distance minus, less than or equal to current distance minus 100. I think it's like that. Dang it, it's the same number. Okay, wait, let's do this again for 64. 1, and then 66. Oh no, why is it 1 for 66? Oh, because I gotta account for the +2. Yeah, there we go. Okay, so if I account for the +2 here, does that change much? Oh, it actually does change it quite a bit. Yeah, okay, that was my bad. Apparently the 2 picosecond cheating rule was deprecated several milliseconds ago. Oh boy. You can only have cheat mode once. Okay. So I think my approach actually kind of scales for this. Kind of is a strong word, actually, looking at my current code. What can we do? Yeah, basically at each point we want to get all the neighbors, right? And now we kind of do need the cheat set, though, I think. Oh, but I don't have what's a way I could do this? Let's just do a map, actually. Actually, well, no, we just need everything for a starting point, so we can just do it in here. Cool. Okay, so basically, what do we want to do? we're allowed to kind of cheat directly through, right? So we can just add the Manhattan distance at each point. So actually, let's do this. If not, part 1. So this is all part 1 code except for the set, which I will move. Right. So then we have, I think we still have this. I don't know why I did that. Control X. Okay, and then actually, no, let's just do a for loop. We're gonna basically just add all the neighbors. So we're gonna do a mega neighbor set. All right, we can do for coordinate C and all neighbors dot. Oh, we can't do it in the same thing, right? So we do set coordinate new all neighbors new all neighbors dot add c dot neighbors. Oh, get neighbors c dot x c dot y grid. What? Required type coordinate. Oh yeah, add all. Then we can do new all neighbor. Well, actually, let's do it here. New all neighbors dot add all neighbors, and then basically for coordinate c and all neighbors. So first of all, if c dot x, well, it's fine if they're equal. That's obviously not going to be faster if it's equal. And neighbors checks for type safety. So all we need is if c, what is this, grid c dot x c dot y does not equal 2, like we don't end in a wall, again, that's not possible, then we do this. Except this is c dot x c dot y plus math dot abs c dot x minus I plus abs c dot y minus j. Like, that's the Manhattan distance, right? That's what we care about. And we add it in. Okay, and then at the end we can do, that way we don't have duplicates randomly. I don't think we should have duplicates anyways, to be honest. Oh, that didn't work. Why not? So all neighbors, can we just do a quick, how big is all neighbors? It's always size 0. Oh right, I never, front of this line as well. I just deleted it, didn't I? Well, we need to start with something in there. Yeah, okay. That seems like a reasonable size. That was about 800 neighbors. That seems like a bit too many cheats, though. Oh no, that was right. Wow, that's a lot of cheating going on. I guess if you're allowed to take 20 steps to the grid, yeah, that's a lot, because there's like, there's like somewhere probably averaging like 700 different potential cheats from any square. And I guess this grid is huge, right? It's like 100 by, is it 140 by 140, I assume. So that's what, 20,000? So 20,000 times 700 possible cheats. Yeah, okay, I can see why the number gets into the hundreds of thousands. Yeah, that's pretty crazy, but makes sense. All right, well, honestly, that's a pretty good day. Rank 411. I think my part 1 lent itself very well to part 2. I can literally, I think, just change this from 20 to, well, 1, I think, right? Let me try. I'm actually curious if that's true. Nope, I can't. Okay, maybe it's not as simple as I think. Um, hmm. I'm surprised that didn't work, not gonna lie to you. I really thought that would do it. Well, whatever. I do think I set myself up well though with the BFS and the BFS2. Terrible naming system, but I think I got the job done. Yeah, but yeah, cool short day, sub 30-minute day. Um, yeah, it's been an interesting trend. These past few days have all been quite easy. I'm ready to get a bit knocked off my socks in the last few days, but we'll see them when they happen. See you for day 21.